So we're finding another derivative, this time with respect to t. But notice that's just because we're using t as the variable. Normally when we take the derivative, we're taking the derivative with respect to x. But here it's t because our function's on t. So first off, we definitely just want to kind of rewrite the function a little bit and make it look better. Because that's just 2 over t. And then, well, let's just do the same thing. So again, let's write it down. What is the formula for the derivative? The limit as h approaches 0 of f of x plus h minus f of x over h. And then we're just going to plug everything into that and then just do our best to not mess up the algebra. So f of x plus h, 2 over x plus h, minus f of x. So just, I'm going to go ahead and do it in terms of x. Just know that we're doing x. It's supposed to be t, but the variable you use doesn't really matter. So 2 over x plus h minus 2 over x over h. And so again, it's the limit. So it's just one of these classic limits. We just got to simplify. And then once we simplify, we'll be able to plug in 0. So what can we do to simplify? Well, you got the fractions. I mean, anytime there's two fractions added or subtracted together, I'm like, well, we can't do any nice things to divide them because it's two things added or subtracted together. But if we combine those into one fraction, then we can do some good stuff with it because then we can actually like divide it by h meaningfully. So I would combine these into one fraction. So how do I do that? I mean, it's just a pattern of common denominator. So I'm going to do that times that, 2x, minus that times that, minus 2x plus h, over that times that. So that's just finding a common denominator. But it kind of blows a lot of people's minds a lot of the time when they see that, of how easy it can be to think about. And see, this is nice because now it's just a fraction divided by a fraction. So now we can just keep change flip and go ahead and simplify the top a little bit. So again, shouldn't forget to copy down the limit. Limit as h approaches 0 of 2x minus 2x minus 2h over, I guess maybe I should do that, maybe not, but times 1 over h. Okay, so what happens now? We'll look how these 2x's go away. Just like a lot of happens without the h's are all gone. So now we can cancel out this h. And so what do we have now? Now we have the limit as h approaches 0 of negative 2 over x squared plus xh. And see how now there's no problem plugging in h equals 0. Now we just plug in h equals 0. We get negative 2 over x squared. And then let's go back up and let's think about, does that make sense based on the power rule? If you know the power rule, and it does. So we're good.